It's a pleasure to have the opportunity to present on a topic that is very important as well as impactful. The topic is wastewater to resource. So during this presentation, we will be discussing around about the importance of conservation as well as how we can have that industrial point of view to safeguard as well as save the water. Okay, so let me introduce to Spray Engineering Devices Limited, a company which has been working on sugar, jaggery, distillery and different areas of technology. The mission statement is dedicated for sustainable environment development to unlock perpetual food and energy resources. Vision is to be integrated player in energy sector. So we value respect, integrity, innovation, ownership. So that is our values. So these are the main key areas where the company is in. 32 plus years of expertise, then 20 plus energy efficient products and different locations, many awards and patents, as well as more than 1500 plus of working force, which is driving the company to achieve the targets. So these are our global presence. We are in Poland, African region, Thailand. So we have done few projects in Brazil, USA as well, multiple projects in USA and Indonesia, and in India number is around more than 600 plus. He is our founder, Mr. Vivek Verma, Managing Director. So he has a vision and we are driving that vision into the reality. So we have started with the mechanical vapor recompression quite some time, and now we are one of the bigger player in this area, and we have been showcasing our facility MVR based system in distilleries, in wastewater, sugars as well. So there are many key areas where we have represented ourselves as a boiler free company which is providing the system without using the boiler, and these are our intellectual assets. So IPR, patents, trademarks and copyrights on different areas. So these are the vertical segments: sugar, water, jaggery, biofuels as well as product concentration. Many of our installation in India as well as abroad. So now what is actually wastewater to resource? So suppose we have the wastewater, then we are screening it, we are treating it, and then some purification, and after treated water it can be used as a clean water for the industry. It can be used, the recovered material can be pressed mud and other part can be used as a biogas. The nutrients, whatever the waste is there, it can be given to the plants, and then in some cases there are some heavy metals which can be recovered from the waste which is part of that wastewater. So it protects the environment, conserve resources, creates values as well as sustainable future, which should be the focus of everybody nowadays. So these are the water conservation areas. So first one is the rainwater harvesting. Usually we have seen in our earlier scenarios also, in the many decades back or centuries back, the people used to have that well, and they are conserving the water. Whatever the rainwater was coming, so it is going into the bore well, so that the bottom, that underwater can be replenished. Then wastewater recycling and reuse should be there. The efficient irrigation methods now has come up because of the water scarcity. So it is drip irrigation, sprinkler system, so that we can save the water and have the more output. Groundwater recharge is also there because the groundwater is getting depleted. So percolation tanks, recharge valves. Alternative water resources like treated water can be used in the park and for washing areas, for other areas where the normal water is no longer used. Closed greenhouses, this is a new concept, and people are also working on these areas where the 90% less water consumption is there and the output is not even hampered. So output wise it is giving more output compared to the earlier irrigation systems or polyhouses. Urban planning solutions like permeable pavement, so that whatever the water is there, it should to recharge the underground water, and rainwater harvesting system should be in place. Treated, semi-treated water for industries, like suppose if industries which are not in the food and beverages, so those industries can use the treated water for their washing, cooling tower and other purposes, so that all the potable water should not be given to the industry, but the reused or recycled water can be provided to them, so that the industry should not suffer. So repercussions of industrial waste, like what will happen if the industrial waste will not be treated, or it will go unchecked. Like we have seen earlier also that untreated or poorly treated wastewater is entering into the rivers, lakes, and then it is also making its path to the groundwater. So in few areas the groundwater TDS is becoming very high, the arsenic and other contents are increasingly becoming very high, and it is acting as a hazard to the health of the people which are residing nearby to those industries. So toxic chemicals contaminate drinking water, aquatic life is also harmed. It leads to diseases like cholera, typhoid and other part. So lots of biodiversity disruption in food chain. So there are many things which has come up during the recent decades we have seen so far. So we need to have a check on that industrial waste. Though the norms are also there, compliance is there. So, but we need to focus on that one. So water importance for the coastal regions. So recently we have seen that during this recent war like Iran-Israel war, we have seen that there was concerns regarding the food safety, gas, oil. During this region we have also seen that there were targets of the desalination plants of those areas, because in the coastal regions, so we have that desalination plant which is catering to the potable requirement of the throughout area. So Gulf region we have more desalination plants, and these also has come up in India as well. So this is Minjur desalination plant which is in north of Chennai. It is supplying around 100 million liters per day as a potable water given for the potable requirement for the people, and it is around 10 million people are getting benefited from this desalination plant. Nemeli desalination plant, that is also in South Chennai, as well as in Manori desalination which is in Mumbai, Maharashtra. That is again 200 mld, but that is for the industrial as well as those requirements where the exact potable water is not required. But now the concern is about the North Indian people or the people which are of the coastal regions. So if we are going to have that wastewater more, or the industrial waste become mixing in the rivers and other part, so it becomes very difficult to have the potable water in these areas, and around 1% is the accessible. So what will happen to those areas which is having the water but that is polluted? So in that case, so we do require some norms by the government as well as the industrial participation also to have those things checked. So what is in circular water economy? So like with reference to the industry, it means shifting from the traditional take, use and discharge. Usually what earlier people were using, that the industries were using the water and then they are discharging. Though they are having their system, that they are ATPs there, everything was there. So though the industries are more concerned, so they are not directly discharging it, but they are treating it, but still that water is not as useful as earlier it should be. But the factors which can minimize the water wastage nowadays is like the water demand should be reduced, like cooling towers, wet cooling, scrubbing system, they should be avoided because these are taking more water into the atmosphere, so they are grizzlers of water. And treat and recycle more water, digital monitoring and smart water system, policy and pricing and governance should be there, like government is having that norms also. So now more models are coming up with the ZLD system, that even if the industry is not agreeing to the ZLD system, so they are not giving the license to operate those industries. So that part also is there. Closed greenhouses as well as drip irrigation, that is a part of those agri companies which are involved, so that there should be less water requirement in those areas. So what is the difference between the linear and the circular model? Earlier people are extracting the water, they are using it, they are treating it and then discharging it. So that is the normal linear model which the companies are following from decades. But now the circular model has also come up in place, where first the company has to, or industry has to reduce the requirement of their water, then reuse it, more focused on the reuse as well as recycle, and then they have to recover it as well as again they have to recycle. So this is a circular model where once the water has taken by the company or the industry, so it is not discharging directly whatever they are taking. It's a portion of makeup water is taken from the outside, rest they are recycling inside their premises. So those companies which are in like textile, so in those regions like in Balotara, Ahmedabad area, where the groundwater TDS is becoming around 3000, 4000. In those cases, the recycled water is much beneficial compared to the normal water, because the TDS of those recovered water is coming around like 50, 100 TDS. So that water becomes even much more better for their product as compared to the groundwater which they were using earlier, and that too at a price governed by the local people. So this is the current scenario. What actually SEDL is doing is, so this is the current scenario which we were discussing earlier, like wastewater is coming, pH adjustment, clarifier, aeration, secondary system. So all those taken into scenario, and then the land requirement also for these one is little bit higher side. So what we have done is we have replaced these system thoroughly with this one, a single system where we have put the MVR system, and whatever the vapors are coming in, we are compressing it and then generating the clean water. Whatever the reject is formed inside the system, so we are rejecting it. After rejecting, there are drying methods, maybe pedal dryer, DFD and other solutions which are available depending on the stream which we are using or the salt which is present in the system, so that we are designing those things also. So this is the simplified process with the LTE model which we are right now providing to the industry. So this is the conventional method, in which normal ME method where the boiler is used. It is also using the fuel and then turbine and then steam. Again the cooling towers are there which are taking the water, and the condensed water is going to the atmosphere and the concentrate is getting generated. So in this one we have added our system, multiple effect same system, but we have eliminated the boiler as well as the cooling towers. So the requirement of the external water for the cooling tower is minimized. Whatever the condensate we have recovered, we can totally use that condensate into our industry or the setup. So that is a simplified evaporation system with the LTE model. And this is the one model like LTE. So it is again added with the FC depending on the concentration or the requirement of the industry, whether it is a ZLD or it is a normal system. So what is MVR based LTE? Like advanced vacuum based technology, boiling occurs below normal temperature. It is under vacuum, so evaporation takes place at 20 kPa, 18 kPa, 22, 25 kPa, and high water recovery is there. So steam requirement is also very less. Only once steam is required, suppose the ambient condition is around 20 to 25 degrees, then evaporate the system, and then the system is self-reliant, like whatever the electrical power it is taking, it is generating the thermal heat and then using the same. So the output water which is high quality water, suppose the initial TDS is like 50,000, 1 lakh, but the TDS of the condensate which is coming in the system, a normal system of textile or some salts like sodium chloride or other part, it is around 50 or 100 TDS, so that is quite good. So what exactly powered the LTE system? So this is the model of that plate pack. So we can see that this is the feed side in this one, and the vapor side is the red colored, and the opening is around 9 mm. So we have few punch plate also with 12 mm and more openings which is coming up in our newer models. And this is a single bundle plate pack. So a pack of these bundles is adding to the heating surface area. So we design the heating surface areas depending on the requirement of the industry and the type of the salts which are present in the system. So MOC ranges from SS304, 316, 316Ti, duplex. Even now we are considering that titanium punching is also has come up now in our system. So understanding the MVR system design, suppose now we have discussed about the wastewater recovery and the importance of water conservation, everything is there. So how to design the MVR system? So data which we usually get from the wastewater industries are like flow rate. They will say that okay, this much amount of water is available, let's say it's a 10 meter cube per hour or 20 meter cube per hour or 2 meter cube per hour depending on their waste which is generating and the type of the industry. So they will come up that this is the wastewater and this is the TDS, some TSS is there, and the pH. pH can be, it is around 3 to 4, 4 to 5, or it can be 10, 11, 12 depending on the type of industry, which is like textile, it becomes more basic, and electroplating it becomes acidic. And their requirement, like they want that 90% water can be recycled, that rest we will manage with our old system, or it's a ZLD solution, like They will give us the wastewater, we will give the solid material outside and all the recovered condensate to them back for their initial use. And the treated water parameters, which varies from state to state. Every state has a different type of PCB norms, but more or less it is almost same, but few areas it deviates in some cases, like COD content, BOD and some TDS content for the treated water, in case that they want to discharge it outside. Suppose if they want to use inside their plant, so that can be used in the cooling towers, on washing, and there are many other areas where they can use that treated water in their premises. So these are the factors which or the data which the industry provide to us. What additional requirement which we have, so these are the requirement like COD or BOD in the stream, how much is there, because ultimately for the condensate treated water we have to ensure that it follows the PCB norms, otherwise there will not be of any use. So higher TSS, in case the TSS, the total suspended solids in the system is very high, in that case we recommend them pre-filtration system. Boiling point elevation, it is also quite important, because how much delta T we need to give to our MVR system. So that part, single or multiple, that is on our part. The total area which they provide, so we decide whether single is more optimized or multiple effect is more optimized. MOC is the major concern, like people treat the waste as a common, like if textile industry is doing in SS316, and electroplating thinks that we can do on the same, or any other industry where the acidic component is more in percentage, so in that case it becomes very difficult. So we have to design the system with the proper material of construction, so that the life of this system will be around 10, 15 years, 20 years, like that. And the nature of salt or the concentrated feed, to select the final drying method, whether we will be using the filter press, decanter, paddle dryer or any other area. So that is the nature of the salt, what type of salt is getting formed in the system. So difference between the evaporation and drying, like we have discussed about these MVR design and MVR system, that is the evaporation part, but the major evaporation and drying system, there is a little bit of difference. Like evaporators is used where the more volumes are getting evaporated. It can be in the single, multiple effect evaporator, and forced circulation depending on the higher TDS. If the TDS is becoming more and more, in that case we use the forced circulation evaporators. But the drying is a process where the moisture content plays a more important role compared to the volume of which is getting evaporated. So for these areas we can use fluidized bed dryers, paddle dryers, ATFDs and many other tray dryer also examples in which, but that too depends on how we are handling the system, like how we are designing the system and what is the total moisture content present in the system. This is the typical example of our drying equipment, which is the paddle dryer. You can see that feed is getting in from the paddle disc, and compressed vapor as well as NCGs are coming on the calandria side or their shaft side. So the compressed vapors of higher temperature, it enters into the shaft as well as that pedals. They heat it up, and the moisture which is present in the feed, it gets evaporated. So both options are available in this section also. It can be in like vacuum as well as atmospheric condition, both options are available. And whatever the solid discharge we are getting from the bottom of that paddle dryer. So it is a continuous system in which the feed is getting inlet from one side, and we are getting the solid discharge as well as clean condensate or water from the outside. But this clean water is the vapors which are getting condensed from the system. If we want to recover that vapors which are coming out from that solid material, so then in case we have to provide another catcher or something with the paddle dryer, so that whatever the vapors which we are getting from the paddle dryer, it gets also condensed and we can take that also. Thank you everyone.